Hello children, how are you all? Hope you all are fine and doing well. My name is Naresh. Welcome to our channel Physics Plaza. Children, in a previous class we discussed about electrical energy and electrical power, and even we discussed about the commercial units of electrical energy, and there we discussed different expressions to calculate electrical energy and electrical power. In this session we are going to learn about power rating of a common electric appliance. You can take any electric appliance, dear children. Every electric appliance has its own power rating. Means electric appliance like a bulb, fan, refrigerator, geyser, mixie, grinder. You can take any electric appliance. Every electric appliance is rated with some power and voltage. Now today we will see what is the use of knowing the power rating of electric appliance, and what information do we get from that power rating. Let us see. For example, dear children, let us take an example. For one bulb, let us say for an electric appliance, the power rating is given like this. It is power rating of an electric bulb, let us say it is 100 watt and 220 volt. It is given like this. A power rating of an electric bulb is given as 100 watt 220 V. First of all, what is the meaning of this statement? Children, in examples they will ask you the question. So for a given electric appliance, the power rating is some 50 watt and 110 volts. Then what is the meaning of the statement? They will ask you to write the meaning of the statement. So first let us see what is the meaning of this statement actually. Children, this can be written like this. So we know that what can be written as joule per second. What can be written as joule per second. So here we can write as a 100 joule per second, comma 220 V. So this can be written like this. But still it is not clear. We don't have a clean information from this. What can we say, children? So as I said that it is a power rating of a bulb, right? Let us take this bulb. Example, here is a bulb. It is connected to the power supply of voltage 220 V. So when it is operated, when it is connected within the circuit, what happens? It starts glowing. As it starts glowing means what? Some light energy we are getting. So from where we are getting light energy? Already we discussed. So it happens just because of what here? Electrical energy is converting into light energy. Means what here? Electric bulb is consuming some energy. How much? That information is given by this statement. So this particular appliance of power 100 joule per second 220 V, which means this electric bulb will take 100 joules of electrical energy in 1 second. 1 second when it is connected to the power supply of 220 volts. So that is the meaning of what actually? The power rating. So I repeat once. So what is the meaning of this statement? It means that the electric bulb, when it is connected to the external power supply of 220 volts, it consumes, it takes 100 joules of electrical energy in 1 second. Okay, that is fine. But still, what extra information we will get? Children, sometimes what happens, due to the power fluctuations, sometimes, especially bulbs and electric appliances, they'll get damaged. Means what? Sometimes more power is supplied. For example, more current is supplied to the electric appliances. Definitely what will happen? They'll get damaged. Even when you can take electric bulb, it will get fused actually. Means every electric appliance has certain limit. So here, by knowing the power rating, dear children, we can calculate that limit of the current. So we can calculate the safe limit of current, first point. And what more we can calculate? Even we can calculate the resistance of that particular electric appliance when it is being operated. Now let us see how can we calculate the safe limit of current. So first, from power rating, we can calculate the safe limit of current, let us say. Children, here it is 100 watt is a power is given. For this particular bulb, we are trying to calculate the safe limit of current. So 100 watt is what? Power is given 100 watt, and here potential difference, that is 220 volts is given. 220 volts. Children, in a previous video we discussed various expressions for a power. Let us recall once. So we have P is equal to V got. So now these two expressions are very important. Now let us take this P is equal to VI. So here P is equal to VI. So as P is equal to VI, dear children, can you write like this? I is equal to P by V? Yes, we can. Now you substitute these values here. So it will be 100 watt by 220. So if you can calculate this, you will get approximately it is 0.45 amperes. Approximately we will get a 0.45. So which means what? This is what actually safe limit of current. So as I said that this is a power rating of an electric bulb I said. So this is what actually safe limit of that particular bulb. Safe limit of that particular bulb it is. Means what will happen when up to 0.45 amperes, dear children, this bulb can work properly. But when current exceeds this limit, then what will happen? The bulb gets fused. So this is how we can calculate. Children, like this, for each and every electric appliance, we can calculate the safe limit of current. Now let us see how can we calculate the electric resistance of an electric appliance when it is being operated. So children, now let us consider this P is equal to V square by R. P is equal to V square by R. So from this, can we write expression for R like this? R is equal to V square by P. So 220 whole square 100 watt. So this can write like this, 220 into 220 by 100. Okay children, now here 0 cancel, this 0 cancel. Now 22 into 22 will be how much, dear children? It will be 484 ohm. 484 ohm. So this is how we can calculate the electric appliance, what a resistance of that electric appliance. So children, this is the resistance of the electric appliance of this bulb. Resistance of this bulb of power rating this much. But here when it is glowing only, then we will get one doubt. So when it is not glowing, it has some resistance. Whether that resistance will be less than this or equal to this or greater than this. Children, you think what will be its resistance? When it is glowing, its resistance is 484 ohms. It's fine. But before glowing, before connecting in a circuit, what it will be? Definitely before glowing, dear children, what will happen? You know, its resistance will be less than this 484 ohms. The reason is that already we discussed the factors on which resistance depends. We know that R is directly proportional to the temperature. Children, when the bulb is glowing, obviously the filament gets heated. As the filament gets heated, what will happen? Its temperature increases. So as temperature increases, its resistance also increases. So which means what? When it is glowing, when any electric appliance, when it is operated, obviously its resistance increases. When its resistance increases, obviously there will be some electrical energy wastage will be there. Okay children, fine. So this is how actually 2 points. Children, I repeat once. By knowing the power rating, we can calculate the safe limit of current, that is 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 equal to P by V, and also we can calculate the resistance. So resistance of that particular filament which is there in electric appliance when it is being operated, we can calculate. Okay children, just copy it. Children, now we will calculate the household consumption of electrical energy. Children, some or the other way, what will happen? We all are using electric appliances. So every electric appliance can consume some amount of electrical energy, so they can work. So during that process, you know, it might be electrical energy to light energy, electrical energy to mechanical energy, electrical energy to what we can say heat energy, whatever may be the use actually. Every electric appliance can consume some amount of energy. But for that we are charged. Dear children, every month, you know, every month we will be paying the electricity bill actually. So on what base we are paying actually? So we are paying electricity bill for what? For the electrical energy consumed by the electric appliances which we are using. But how can we calculate? How can we calculate the electrical energy consumed? Dear children, so the electrical energy consumed can be calculated in terms of kilowatt hour. Children, whatever the electric appliance, whatever the electrical energy which electric appliances are consuming can be calculated in terms of kilowatt hour. Children, this kilowatt hour only we can call it as a 1 unit. We can call it as a 1 unit. Now, let us see how can we calculate that electrical energy. Children, we know that electrical power is equal to electrical energy by time. Am I right? Yes. So then electrical energy is equal to, can we write power into time? We can write. Now let us see here. So here electrical energy is equal to, here you may get a one doubt. So whenever we are calculating, generally time will take in a seconds. But why are we taking here in hours, dear children? So calculating what electrical energy consumed in 1 second for any electric appliance will be very less. So it will be neglected. So that is the reason why do we calculate electrical energy consumed per 1 hour actually. So children, this is the main formula which we use to calculate the electrical energy. Children, it's a very important thing. Power always must be in kilowatt. But you may get a one doubt, sir, if power is not given in kilowatt, what we have to do? We have to convert that watt into kilowatt. How? Like this. If this power is given in watt only, okay, it is given in watt, and time is given in hours, then divided by 1000, then you can calculate the electrical energy. But dear children, sometimes power may not be given, voltage will be given, current will be given, time will be given. How to calculate? For that also we have a process to calculate. Children, we know that power is equal to V into I. Now in the place of P, just substitute VI. Then here we get, in the place of P, let us substitute V into I. What are we going to get? V is in volt, so it's very important. And current, it is in amperes. And time as usual in hours only. By it is 1000. So children, these are the 3 formulas which we use to calculate the electrical energy consumed. But dear children, what are the electric appliances which we are using? Do you think that every electric appliance has the same power? No, it is not that. Different electric appliances have different powers. That is the first point. Now second point, do you think that every electric appliance is operated for the same time? Like a bulb, fan, refrigerator, TV, like a daily 2 hour only every object. It's not that. So we cannot use all electric appliances for the same time, like using only 1 hour. Like it is not that. Means different electric appliances are operated for different times actually. Means you may use fan for 1 hour, TV maybe 4 hours, refrigerator maximum total day it will be working. So geyser in a winter you will use much, AC you will use much in summer actually. So that is the difference. So different electrical appliances with a different powers are used for different timings. But as we are calculating electrical energy for different appliances, then how, what method we are going to follow? Children, here we have 2 methods to calculate the electrical energy consumed. Let us see that. Dear children, here we have 2 cases. Let us see individually how to calculate the electrical energy consumed individually. Let us see. Children, in the first case look at here. So bulb of power P1 and a fan of power P2 and a TV of power P3 and AC of power P4. For suppose example, it is ideal case, it is not possible practically. If all electric appliances are used for same time T only, it is used T hours only, T hours only, T hours only, T hours only, then how to calculate the electrical energy consumed? So children, in this case especially, we can calculate electrical energy consumed is equal to, so total power we have to calculate first, that is P1 plus P2 plus P3 plus P4. Let us add. First add the powers of all electric appliances into time. That's it, into time. That's it. So we will get the total electrical energy in kilowatt hours only. But it's strictly powers is in kilowatt hour only. If not, we have to convert into kilowatt and then we have to add. Children, this is how we can calculate the total electrical energy consumed when what are different electric appliances with the different powers are used for the same time. Let us come to the case 2. In the case 2, if you can see children, so this actually practical case where different electric appliances are used for different timings, different times. Now let us see how to calculate. Children, now what we have to do, we have to calculate the electrical energy individually we have to calculate. So for this bulb, what is electrical energy consumed? That is P1 into T1. Children, don't forget that here P is in kilowatt and time is in hours only. That you have to keep in your mind. So here, what is electrical energy here? Electrical energy will be P2 into T2. And electrical energy consumed for TV is how much? It will be P3 into T3. So the electrical energy consumed by AC is how much? It is P4 into T4. So now we got electrical energy consumed individually, consumed by bulb, fan, TV, AC. Now to calculate the total electrical energy, then what we have to do? We have to add all these energies. So this is how actually. So electrical energy is equal to, now let us add here, P1 T1 plus P2 T2 plus P3 T3 plus P4 T4. So finally we will get electrical energy in terms of kilowatt hour only. So children, this is how we can calculate the electrical energy consumed by different electric appliances. Now we will see one example, we will see, so that you will get a more clarity. Children, look at this example. So what is given here? It is a electric AC. Okay na? So its power is given 2500 watt and it is operated 2 hours per day. Then they are not asking us to calculate the electrical energy consumed per day. What they are asking? They are asking per month we have to calculate. Per month we have to calculate. Children, let us take electrical energy formula. What is that, children, here? So electrical energy. So here time is given 2 hours. That is happy, no problem. But here power is given how much, dear children? Power is given how much? 2500 watt. 2500 watt. So when power is given in watt, dear children, you have to convert into kilowatt. So this will be by 1000 means how much will 2.5 kilowatt we get. Now substitute here 2.5 kilowatt only into time 2 hours. So this will be 5 kilowatt hour. But dear children, don't forget that it is per day only. This is a electrical energy consumed by that particular AC when it is operated for 2 hours daily. But month means, acha children, month means we may get one doubt. Sir, February 28, some other month 30, some other month 31, then which one we should take? Children, and an average generally month means we take 30 days only. We calculate for 30 days only. So it is per day. So if you want electrical energy consumed per month, what we have to do? We have to multiply with 30. So then you get 150 kilowatt hour per month. Kilowatt hour per month. So children, this is how we can calculate the electrical energy consumed. Then how can we calculate then electricity bill, cost of electricity? Dear children, our government, they will charge. So they will fix a particular rate per each unit. For suppose I am saying you. So they are for example 4 rupees per unit, let us say. So 4 rupees per unit. So in this case, let us calculate. So if we have only AC and it is operated like 2 hours daily, then per month what is the electricity bill if government is charging 4 rupees per unit. So children, look at here. So 150 kilowatt hour. So this what actually we got electrical energy per 1 month. Children, this only we can write as a 150 units. 150 units. Then how to calculate electricity bill? Children, look at here. So here cost of electrical energy is equal to so electrical energy consumed per month, total electrical energy consumed into cost per unit. Cost per unit means per each unit how much they are charging. So here just simple, total electrical energy consumed into cost per unit is 4. So if you multiply, how much you will get? 0, 0. So it will be 6 rupees. So this is how we can calculate. But dear children, do you think that only we will be having only one electric appliance in our house? Is not that. So we will be having more electric appliance will be here. But this is how. For example, if one more extra electric appliance is added, what you have to do? First you have to calculate like this only. Whether children, whether one electric appliance, 2 electric appliance, 3 electric appliance, whatever it may be, the method is same. So this is how we can calculate the total electrical energy consumed, and we can calculate what we can say the cost of electrical energy. So how we are paying each and every month. So this is what actually. Okay, children, copy it. Now we will see heating effects of current. Dear children, if you can take any electric appliance where it is operated for some time, try to touch. It may not be electric heater, electric geyser only. You can take a bulb, you can take a fan, you can take a grinder, fridge, any electric appliance, children. So when it is operated for some time, then what happens? Obviously, so there will be some heat is produced. So there is some amount of heat is produced. So how to calculate that? So now we will see on which factor does the heat produced depend. It's very important. For that, let us take one simple circuit, children. Here is a resistor whose resistance is R, and it is connected to the battery, and here is key. It's very important. It's a key. So when it is operated, like when the switch is on, so that what happens? Current start flowing. Let us say I is the amount of current which is flowing through this resistor. In a time t. How long are we allowing the current to flow through that circuit? Time t. So then H is the amount of heat produced. Children, this amount of heat produced depends on here 3 factors. It depends on resistance of the resistor, the amount of current which is flowing through the circuit, even time also. So here first factor, it depends. H is directly proportional to the square of the electric current which is flowing through the circuit. So children, it is noticed that when less amount of current is passing, less is the heat is produced. When more amount of current is passing, more is the heat is produced. So second point, it also proportional to the resistance of the conductor. Children, already we discussed, if more is the resistance, then what will happen? So it offers more resistance, which means what? It will try to stop the flow of charges. So children, so their energy should not get wasted. According to law of conservation of energy, what will happen? That electrical energy should get converted into heat energy. See, not only heat energy, can be in any other form, but in this case what will happen? It gets converted into heat energy. So more the resistance, more the heat is produced. Next, it also depends. Children, this you might have noticed. For example, dear children, a bulb is operated 1 hour. One bulb is operated for 1 hour, and one more ideal bulb is operated for 5 hours. In which case, do you think that more heat is produced when you try to touch the 2 bulbs? Obviously, you can say that the bulb which is operated 5 hours only, in that case only, we feel more heat actually. Which means what? Here time also factor which is deciding the amount of heat produced. So here, more the time, for more time you can operate electric appliance, so more is heat is produced. So that is H is proportional to T. So children, very important here. So H is proportional to I square, H is proportional to R, H is proportional to T. This only we can write like this. So how can we write here? H is proportional to I square R T. So this only H is equal to, here let us take here J is a proportional constant into I square R T. We can call it as a Joule's law of heating. Actually, children, when you go for higher studies, you will, that is especially in a +1, it will be discussed more. Actually, children, did you remember what is this I square RT? What is I square RT? I square RT is nothing but what? Electrical work done, which we discussed. So we can write this H is equal to J into W, J into W. So J is a proportional constant, right? So H is proportional to the work done, or this is electrical equivalent to electrical energy, which means what, children? More the electrical energy, more the heat is produced. Less the electrical energy, less the heat is produced. So here J is a proportional constant. It can be like replaced with H is equal to 1 joule is equal to what? 0.24 calories. So you can write 0.24 I square RT into calories. But usually, dear children, we will calculate in joules only. So this is what actually heating effects of current. So when current flows through any electric appliance or any resistor, some amount of heat is produced. So on which factor does the heat produce depend, dear children? It depends on these three factors. Okay, dear children, hope it's very clear to you all. Okay, so in the next session, dear children, so we will be solving the numerical. Children, it's very important. So what are the numericals which we are going to solve, dear children? So not only important for your board examinations, but also for competitive examinations, they are very important. Okay, dear children, thank you so much. All the very best.